Okay, so about the perceptron. The perceptron takes an input vector of p variables like x that can be equal to what? To x1, x2, to xp, and builds a nonlinear function like fx as the predict the response y. Then we want to know about it. It could be the result of the loan or the default or not default of a loan application. So accepting or not accepting of the loan application. So it could be a binary variable with two values. And then we have a vector x that is what? That is x1, x2 to xp, and it belongs to Rp, right? So if we imagine that we have a feed-forward neural network, P means what? P means that simple feed-forward neural network for modeling the quantitative response with P predictors. So we have P predictors, and they are as what? They are as input layers. The input layer of our neural network. Imagine that we have the x1, x2, and xp as the input layer. And the goal is what? The goal is that we have this y as a response by ingesting these x's into our neural network. So if we imagine a perceptron here, these are as the inputs, so with some weights. The weights for the x1 could be beta 1, the beta 2 for x2, and the beta p for xp, right? So here we can have also beta 0. So in this perceptron, what we have, some x's that they are ingested into our model. This is a vector x that we have it here. We are looking for what? The fx, and in the middle, in this perceptron, what we have this beta 0, and also we will have a weighted sum of x's with the weight what? The betas that we have here. So the beta I xi, that the I is from 1 to p. Okay? And then something else that we need is a nonlinear function that could be a g as a nonlinear function. That traditionally it was the step function. So this is what? The linear function like a step function. Okay, in a very simple way, we can consider it as a step function. So this input layer fits into each of the hidden layers, the K hidden layers that we might have in our deep learning and in our neural network. And we can have it as the 5 hidden layers, more hidden layers, less hidden layers, based on the problem that we are solving, and increasing the hidden layers to get to the better answer. So finally, this fx is something that we are looking for. That has two values, the -1 and 1. Okay? It could be considered as a default and non-default for the result of a loan, and predicting something about the application of the new customer, given to access that we ingest to our model, and this -1 and 1 is what is a final set. And this is like a classification problem that we want to solve, right? The classification of customers of a bank, or classifying loans into default and non-default. So we have these input layers, we have this perceptron in the middle, we have the nonlinear function that we have to find it, we have to also estimate the betas. So the weighted sum that we have here is important, and this is something that we are looking for when we are looking at the neural network with the different layers. So we have this weighted sum of x's that is equal to hyperplan with the vector beta transpose dot vector x plus this beta 0 that we had it here. Okay, so this hyperplan that finally we have to solve it, and we have to find an answer for the betas, and the beta is what? The vector of the beta is equal to beta 1 to beta p. Okay? So we have this hyperplan, and the goal is to understand the situation if the loan application for the credit risk management should be accepted or rejected, and how we do it by estimating beta 0 to beta k, and how we estimate it by using the optimization methods. Okay. So if we imagine this perceptron here, then we can say that we can have for x1 an activated function in this neural network in the hidden layer that is in the middle. So if we imagine a hidden layer here with a1, a2 to ak, so imagine that this is our hidden layer. And then we have the inputs as x1, x2 to xp. Okay, that all of them could be connected to these activation functions in the middle in the hidden layer. And they have some weights similar to what we had here as the betas that was an input to Perceptron. Here we have this x's with some weight. And we can consider this as the weight 1, 1 for the x1 and a1. For the x2 and a2 we can say w1, 2, and for a1 and xp, we can consider the weight 1p. So for all of them, we have the connections with the x's and also the different activation functions in the middle, in the hidden layer. So this is our input layer. And this is our hidden layer. And this a1 as a function that we have in the middle should be this g, the nonlinear function, with what? With the combination of the weights and the x's. So first, we can imagine that we have a weight similar to beta 0 that we had here. So the w10 plus what? w11 x1 plus w12 x2, and finally we have the w1p xp and this is what we have as the a1 that is dependent to the g that we have here, the nonlinear function that it is important for solving this problem. And also, as we can see, we have the x's here, that they are the observations that we already know about them, but the w's are the weights that we have to also estimate. So if we want to generalize this as the a, okay, the last one, it would be what? The g as what we had here. So these ones should be all transformed to k, but the rest of the indexes would be the same, plus the summation from 1 to p, weights and x's. So this is the general formula that we can have for this edge in the hidden layer. And finally, we want to know about what? We want to know about this function, right? So we have this fx that, as we said, it is a final set of -1 and 1. We are looking for this, and it could be written as equal to what? To beta 0. Okay, similar to the beta 0 that we have here, plus the function that we have, the summation of the weights to what? To this ak that we have in the middle. So this is a nonlinear function of the weights plus the summation of kj xj, j from 1 to p. Okay. So these activation functions are important. traditionally it could be a step function, but we have also the sigmoid function. That is what? It could be as the g that we had in our graph. So the gz, for example, will be equal to what? The ez over the 1 plus ez, or equivalently we can write it as 1 plus e minus z. Okay? But we have the better functions also, right? Like the ReLU function, that is the rectified linear unit. So it is equal to what? Is equal to 0 if z is negative, and otherwise it could be z. So remember, ReLU activation can be computed and stored more efficiently than a sigmoid function. So Perceptron activation function, unlike what? Unlike the neurons that we have in our body, okay? And we have in our brain, so it put the value on the activation functions. The AKs are important here. So if these AK is close to 1, it means what? It means firing, and if it is 0, it means silent, if you consider the sigmoid function, for example. So by looking at all of this perceptron story and also the hidden layers that we have here and the function that we are looking for it, we can see that something that is important to know to apply this kind of methods, knowing about the nonlinear function that we have to have here, and also have an estimation for the betas, that they are unknown, so they are not something that we can observe and we can estimate it. And how we do it? By training our model with the data and ingesting data in our model and training the model based on the observations and finding the best solution that is coming from the computational power, a combination between the computational power and the methodology that we use. So for the next part, we will focus on this hyperplane that we have here and how we can estimate the betas, and also how we can choose the best nonlinear function as the hidden layer part of our neural network.